So let's talk about how we hold the blank tightly in place on the CNC machine. So the blank, here it is, it's going to be supported by some stands, 4 of them, underneath the board that are attached to the floor of the shed. And obviously we can't screw these rods into the foam because we're going to destroy the foam. So on the top of these aluminum rods, which actually these rods pass through a flange mounted on the floor of the shed, and they can travel down or up through a hole in the floor. So on top of this aluminum rod is a plastic disc, and it has an orifice that's hooked up to plastic tubing that's hooked up to a vacuum pump. If you look at the top of the disc, circular disc, it's got a rim that's fitted with a rubber O-ring on top. Here's the orifice, and then this space here is milled out, so it's filled with air, but it has a base. And then we put the blank, the foam, against this O-ring, and when we apply vacuum to this chamber, it's going to suck the blank down tightly against the plastic disc. So this is going to hold the blank tightly in place with respect to the CNC router. Okay, so let's talk about how we align the stands to be true to the router. So let's say this is one of the stands at the nose end of the board, and here's the other one, one near each rail of the board at the nose. And we want these 2 stands to be adjusted in height to be true to the router. So this is easy. We just bring the router bit down until it just touches the top of this stand. Here's the shaft. And then we move it along Y without changing Z until it's hovered above this stand. And then we just adjust the height of the stand until this disc just touches the router. So now the height of both stands is true to the router. That's clear. And we can do the same thing for the 2 stands towards the tail of the board. Another way to look at this is, here is the cross section along the top of the board, somewhere along its length. Here's the bottom of the blank. Here's one of the nose stands. Here's the other nose stand. And the board is put onto the stand so that the center point of the stringer is exactly halfway between these 2 stands. So the computer coordinate file says, well, let's say when I'm 5 inches to the left of the stringer, I should be at a Z value of 2 inches. So here we are. Here's the router bit. This is Z equals 2. And the computer file says when I'm 5 inches to the right of the stringer, the other side, I should also be at Z equals 2. Okay. So since these 2 stands are true to the router, and these 2 router positions are exactly the same Z value, the thickness through the blank from the bottom of the board, from this stand to the bottom of the router blade, let's call it Z equals, let's say 1 inch, will be exactly the same thickness. Over here, Z equals 1 inch, as it should be because of the symmetry of the board with respect to the stringer. So this is all fine and easy to understand. Okay. Let's talk about how we align the blank with respect to the router. The first thing we do is, here's the board looking from the top. Here's the stringer running through the center of the board. We rotate the board along the Z-axis until the stringer is true to the router. So what we do is we just move the router along X from nose to tail, and we insist that the router follows the stringer line exactly. And if not, we turn the board along Z until it's aligned with the X motion of the router. So that's easy. So now we have the blank mounted on the stands. And we're ready to mill the stringer. We do the stringer first because it's wood and it's more difficult to route through the wood, so we do it slowly through the stringer along its length. So what we do is we bring the router bit to x equals 0 at the nose, and we bring it to a y value so it's right above the stringer. And we mill the stringer along its length. And we do this in multiple passes, cutting deeper and deeper into the stringer with each pass until the entire stringer along its length has been milled. Okay? At that point, we don't have any unmilled sections of the stringer, and we know that the stringer has the desired shape as specified by the computer file. So then we bring the router back to x equals 0. We bring it to a z value so it just touches the stringer. And we bring it to y equals 0 on the stringer. And then we mill across the top in a serpentine fashion until we can mill the entire top of the board through the foam. And every time the router passes across the stringer, it rides just above it, so we don't have to worry about the router getting into trouble when it hits the wood. Okay, so suppose you've put the blank in the mill with the deck side up, and you've milled the top of the blank, and now you're ready to mill the bottom. You could do it in the reverse order, but let's say you did the top first. Okay, so now you need to flip it over so that the bottom of the blank faces the router, because we can only cut from the top. So here's one of two stands at the nose end of the board. Here's one of two stands at the tail end of the board. And suppose they're at the same Z value, the same level, and true to the router. So now we flip the board over so that the deck of the board, the top is down, the bottom of the blank is facing above where the router is. Okay, so this is the deck of the board. So let's consider this point right here, which is sitting on the router stand. According to the computer file, it has a certain x, y, and z value. Suppose this is the x value 1 foot from the nose. And suppose we're talking about the center of the blank, we're at the stringer in y value. And the computer file says for this x equals 1 foot, y equals stringer, z is supposed to be 1 inch. Let's consider this point on the deck, which is also on the router stand. Let's say this is 1 foot from the tail. Also, a y value equals to the stringer. But let's say the z value in the computer file is not 1 inch, but ½ an inch. So now we have a problem because the computer file says these two z values are different, yet with respect to the router they have the same z value because they both lie on the stand, and the stand is true to the router. So that's no good, that's wrong. So if you think about it, what we have to do is we have to raise this stand ½ an inch. We have to raise it up. So if there's a ½ an inch difference between this stand and this stand, why do we raise it up rather than down? If you think about it, z equals ½ an inch is closer to the rocker of the board than z equals 1 inch. Because remember our coordinate system, here's the deck, here's the bottom, and z equals 0 is somewhere down here. So ½ an inch is closer to the bottom than 1 inch, so that means we have to raise this up ½ an inch. Okay, that's very important to get it right. And now we're ready to mill the bottom of the board. Take 2. The other thing you'll note is that it's not required that this stand be at an absolute value of z equals 1. All that's required is that the two stands have the correct relative z values. So now what we do is we position our router bit at x equals 0 at the nose. And we run the computer program to mill the stringer of the board. Okay, and we do this in multiple passes because routing through wood is more difficult with foam. And for each pass, we lower the router initially along Z until the final Z values are routed out. At that point, the stringer will look something like this. And the thickness of the board at the nose should be what we want, and the thickness at the tail should be what we want. In fact, the thickness all along the length of the board should be correct. At that point, we bring the router back to the initial stringer position, and then mill the bottom of the board in a serpentine fashion until all of the foam on the bottom has been milled. When the router passes across the stringer, it should ride just on top of the stringer because the stringer has already been milled along its length. So we don't get into trouble with the router hitting wood while it's moving at high speed.